Okay, let's dive in. We all feel it, right? Every single day. Gravity.
Yeah, keeps our feet on the ground. Shapes the whole universe, really.
But here's the thing, and it's kind of a mind bender. Science doesn't actually have a final definitive answer for what gravity fundamentally is.
Which is exactly what makes this document we're looking at so interesting. It tackles that head on.
Right. We're diving into part 3 of Quinta Essentia, a practical guide to spacetime engineering. This part's called metric engineering and the quasi-unification of particle physics.
And it's not just theory for theory's sake. This gets into potentially, well, revolutionary ideas about how gravity works, how it connects to other forces, and maybe even what particles are really made of.
Absolutely. The author, Riccardo Storti, covers a lot of ground. I mean, things like spectral quantization of gravity
Heady stuff, yeah.
and linking it all the way to a quasi-unification of particle physics. And there's this list, a list of scientific achievements.
Which sound pretty bold, don't they?
They really do. Spectral quantization of gravity, validating something called the polarizable vacuum model, an electrograviton magnetic spectrum, and this idea that particles might be like harmonic multiples of each other.
Like notes in music,
Yeah.
yeah. And the kicker is a lot of this is presented as, either experimentally verified or strongly implied to be.
So our mission here, for you listening, is to unpack the main arguments. We want to get the gist of this EGM approach to gravity, how it supposedly links up with electricity and magnetism.
And what it suggests about the fundamental building blocks of everything, without getting totally bogged down in the weeds, mathematically speaking.
Exactly, because we figure you're someone who wants to grasp these big ideas, get those aha moments, but maybe doesn't have time to wade through dense equations.
So we'll keep it clear, keep it moving.
Okay, so this Quinta Essentia document, it starts by questioning general relativity, Einstein's theory. Not saying it's wrong, but maybe not the right tool for certain jobs.
Precisely. The argument is GR is fantastic for the big picture, black holes, expanding universe, all that cosmic scale stuff.
Sure.
But maybe not so practical if you actually want to engineer something with gravity, on a benchtop in a lab.
Right, because GR basically says you need, what, planet-sized masses to really bend space-time significantly?
Exactly. Not easy to replicate in the lab. And the math itself, the field equations, they're notoriously complex. You often need serious computing power just for basic scenarios.
So if GR isn't practical for engineering gravity, what's the alternative proposed here?
Well, that brings us to this electrogravimagnetic approach, EGM for short.
EGM, okay.
The idea is if we want to interact with gravity experimentally, we probably need to bring electricity and magnetism into the picture because those are forces we can generate and control fairly easily.
Okay, that makes sense from a practical standpoint. So what are the core concepts behind EGM? There's the zero-point field, the ZPF.
Right. The ZPF. So imagine empty space isn't really empty. Think of it like a sea of potential. Even at near absolute zero temperature, there's this underlying energy, this fizz of virtual particles popping in and out of existence.
That background noise.
Kind of, yeah. Randomly oriented photons or wave functions flickering at a very low energy level. It's everywhere, this field.
Okay, this background ZPF. How does gravity fit in? That's the polarizable vacuum model, the PV model.
Spot on. The PV model is presented as an alternative way to think about gravity. The author claims it works just like GR in weak fields, like here on Earth.
So it matches what we observe.
In those conditions, yes. But the mechanism is different. Instead of space-time curvature, the PV model says mass polarizes this zero-point field.
Polarizes, like a magnet lining up iron filings.
A thicker analogy, yeah.
Yeah.
Mass causes some kind of alignment or ordering in the ZPF, and it's this polarization effect that we perceive as the force of gravity. And the author argues this simplifies things for our everyday experience because gravity just feels like a pull downwards, right? So in this model, it's effectively treated as a one-dimensional phenomenon for many practical purposes.
One-dimensional. Feels almost too simple, but okay, as a practical model. So how does EGM actually use this? How does it connect to electromagnetism?
This is where it gets really interesting and maybe a bit abstract. EGM uses a mathematical tool called Fourier analysis.
Breaking things down into waves, frequencies.
Exactly. So instead of seeing Earth's gravity as just one constant downward acceleration, G, EGM represents it as a whole spectrum of different frequencies, like decomposing a musical chord into its individual notes.
Okay.
This is called the PV spectrum. It has a base frequency, a fundamental, and then a whole series of harmonics up to a certain cutoff frequency.
A frequency spectrum for gravity itself.
Wild. And within this spectrum, you have these pseudo-propagating wave functions. It's a bit technical, but think of it like this. Each frequency component is oscillating, but they're arranged in such a way that their collective effect, their combined push or pull outwards, cancels out.
So they don't, like, radiate energy away constantly.
Precisely. The net group velocity is zero, which fits with observation planets aren't constantly losing energy by shedding gravitational waves in this model. It's a standing wave pattern, in a sense.
Okay, so EGM describes gravity as this complex spectrum of non-radiating waves linked to the ZPF. But how do we know if this whole picture is right, or even useful?
That's the million-dollar question, right? And the strategy proposed is quite clever: indirect validation.
Yeah.
Meaning, if this EGM model accurately describes the fundamental interactions of reality, including the ZPF and its relation to mass, then it should be able to predict other fundamental properties of the universe that we can measure accurately.
Like particle properties.
Exactly, like the mass and the radius of fundamental particles, protons, electrons, quarks, etc. These have been measured experimentally to high precision.
So the idea is use EGM to calculate what those masses and radii should be and see if it matches the experimental results.
That's the litmus test proposed. If the EGM calculations derived from its first principles consistently match the known measured values for particles,
Then that gives you confidence the underlying EGM model might be on the right track.
precisely. And the document claims that EGM can do this. It asserts that it can derive many known particle properties and that the predictions often match experimental data very closely or fall within the accepted ranges from the particle data group, the PDG.
Wow, okay. If that holds up, that's significant.
Yeah.
And you mentioned something earlier about particles being like musical notes, harmonics.
Yes, that's another fascinating aspect. Within this EGM framework, particles aren't seen as entirely separate entities, but as potentially related through harmonic principles.
How so?
For instance, the author suggests quarks might be described as harmonic multiples of, say, the up or down quark, or even the electron. It's like they are different resonances within the same underlying field structure.
So related mathematically, harmonically.
Right. And the author stresses this doesn't necessarily contradict the standard model of particle physics, our current best theory. It's more like suggesting a deeper layer of organization, a unifying principle based on these harmonic relationships derived from the Fourier analysis.
Fourier analysis again, breaking things down into frequency.
It seems central, yeah. The claim is that this harmonic approach using Fourier series, specifically an inverted harmonic amplitude spectrum and an arithmetic frequency spectrum, offers a, quote, neat and complete harmonic description of the universe, like everything arises from the power of one, expressed harmonically.
This is definitely a different way of looking at things. Okay, assuming this EGM framework has some merit, what are some of the implications, the potential predictions or applications that come out of it?
Well, some are pretty speculative, but intriguing. One is the idea of gravitational telescopes.
Telescopes that detect gravity instead of light.
Kind of. If different masses have unique gravitational frequency signatures, as the PV spectrum suggests, maybe we could build detectors tuned to those specific frequencies. You could potentially listen for the gravitational signature of specific types of objects across the cosmos.
Imagine tuning into a black hole's frequency. Wow. What else?
There's a suggestion about defense applications. Potentially distinguishing real ballistic missiles from decoys with much higher accuracy by analyzing their precise gravitational or EGM signatures, which might differ even if radar signatures are similar.
That would obviously be huge. And what about the bigger picture, unifying forces?
Yes, EGM claims to achieve a unification of electricity, magnetism, and gravity working from the subatomic scale all the way up to super-dense objects like neutron stars.
A unification. That's the holy grail for physics, isn't it?
It is, and the document states the unification holds with about a 5% error over lab scale distances, an error they relate to the cosmological constants effect.
Okay. What about something more? Testable, maybe? I remember reading about the Casimir force. That's a real measured quantum effect, right?
It absolutely is. It's this tiny, attractive force between two very close, uncharged conductive plates in a vacuum. It's usually explained by the ZPF, the idea that the plates exclude certain ZPF wavelengths, creating an energy imbalance.
Right. How does EGM explain it?
EGM derives the Casimir force from its ZPF model too, specifically relating it to the beat cutoff frequency of the PV spectrum. But here's a key difference. EGM predicts the Casimir force isn't constant.
It changes.
It predicts the force should vary depending on the strength of the local gravitational field. The standard view doesn't include gravity in the calculation like that.
Why would gravity affect it in the EGM model?
Because gravity in EGM compresses or stretches the PV spectrum. In a stronger gravitational field, the spectrum is compressed. This changes the bandwidth, potentially altering which ZPF modes get excluded between the plates, thus changing the resulting force.
That's a testable prediction, presumably.
It should be, in principle, though likely very difficult to measure. The document also mentions EGM can predict repulsive Casimir forces under certain geometries, which is something that has been observed experimentally too.
Interesting. And how does the PV spectrum itself behave? You said gravity compresses it.
Yeah, it's quite intuitive. As mass increases towards the theoretical limit of a Planck particle incredibly dense, the spectrum gets squeezed. The lowest and highest frequencies get very close.
Okay.
Conversely, in nearly flat spacetime with very little mass, the spectrum broadens out enormously. The fundamental frequency approaches zero. It's like a dynamic range that adjusts to the local mass density.
And somehow, Euler's constant pops up in all this. The number gamma from math.
Weirdly, yes. Gamma, which is about 0.577, is a purely mathematical constant. But in EGM, it appears in the equations used to calculate the harmonic cutoff parameters.
Which are needed for
Predicting particle properties, like mass and radius. It's fundamental to the harmonic calculations within EGM.
So a mathematical constant is playing a physical role.
That's what's suggested. And the author even speculates that if EGM's prediction for the photon's mass energy is ever verified, you could potentially rearrange the math and find a natural physical limit related to Euler's constant at the quantum level. A bridge between pure math and physics.
Mind-bending is the word. What about other fundamental scales, like the Planck scale or the size of a hydrogen atom, the Bohr radius?
EGM apparently calculates those two, described as experimentally implicit calculations. The Planck scale comes out a bit smaller than the standard value, and the Bohr radius a bit larger.
Why larger?
The Bohr radius calculation in EGM is based on the hydrogen atom reaching equilibrium with the ZPF. It's this equilibrium condition that supposedly sets the electron's orbit. And interestingly, this derivation also naturally yields the Balmer series formula for hydrogen's spectral lines.
Okay. And didn't you mention predictions of new particles? That seems like a big deal.
A very big deal, yes. EGM apparently predicts 3 new leptons particles, like the electron, muon, tau, plus their associated neutrinos, and potentially 2 new intermediate vector bosons, the force carriers.
But the standard model is supposed to be complete in terms of fundamental particles, isn't it?
Currently, yes. The standard model, as it stands, doesn't allow for more generations of leptons or fundamental bosons beyond what we found. So finding new ones would force a major rewrite of our understanding.
Okay, so we have all these claimed successes, these predictions matching known data, predictions of new phenomena. But the skeptic has to ask, could it just be coincidence? Could they just be getting lucky fitting the numbers?
A fair and crucial question. The author tackles this head-on with a probabilistic argument.
How does that work?
They take the example of the proton and neutron charge radii, their measured sizes. EGM predicts these values. They then calculate the probability of getting such precise numerical matches purely by random chance.
And the result?
The probability, labeled pu plus e, is calculated to be astronomically small, something like 10 to the power of minus 38.
10 followed by 37 zeros and then a 1. That's small.
Vanishingly small. Basically zero chance of it being random luck for just those 2 values. And the argument is when you factor in all the other particle properties EGM claims to predict correctly,
the overall probability of it all being a fluke becomes negligible.
Effectively zero, according to the document's analysis. The argument is that the sheer number and precision of the claimed matches make coincidence statistically impossible.
Okay, that's a strong counter to the accidental prediction idea. So wrapping things up a bit, how does EGM claim to solve existing problems or gaps in physics, like with the ZPF or the standard model?
Well, it offers potential answers. For the ZPF, it aims to define its spectral composition precisely using the PV model and Fourier harmonics, rather than just leaving it as an infinite sea.
Giving it structure.
Right. For the standard model, it predicts those new particles, suggesting the model might be incomplete. And it claims to provide a unified way to calculate mass, energy, and radii for all fundamental particles from one framework.
Unlike current physics, which uses different methods for different particles.
Exactly. It proposes a single underlying harmonic mechanism.
Okay, let's try to distill the absolute core takeaways for everyone listening. What's the essence of this EGM approach?
Fundamentally, it's proposing a deep link between gravity, electromagnetism, and the very nature of particles, all tied together by harmonic principles and this concept of a polarizable zero-point field. It's a framework that aims not just to describe, but to predict, potentially opening up new physics.
So for you, listening to this, hopefully you've got a clearer picture now of a potentially paradigm-shifting way of thinking about the universe, from the force holding you in your chair to the tiniest subatomic particles.
Yeah, seeing potential connections where maybe we didn't expect them.
And maybe a final thought to leave you with. Consider the what if. What if gravity can be engineered using electromagnetism, like this EGM approach suggests? What could that mean?
New propulsion, new energy sources, a fundamentally different understanding of reality. It really makes you wonder if the universe is even more interconnected and, well, tunable than we currently imagine.
Definitely food for thought. This deep dive really just scratches the surface, of course. If concepts like the zero-point field, the polarizable vacuum, or particle harmonics caught your interest,
There's a lot more to explore out there. It feels like we're still just beginning to understand the deepest workings of the cosmos.